Based on the application used and the way it processes user-supplied data, SQL injection can be used to implement attacks. One way could be authentication bypassing. Here, the attacker could enter into the network without providing any authentic username or password, and it could gain access over the network. He gets the highest privilege in the network, let's just say that.
Yeah, that's a good way to say it. Yeah, and after unauthorized entry into the network, the attacker gets access to all the sensitive data stored in that database. The attacker changes the main content of the website and also enters malicious content into it. The attacker also uses a compromised data integrity type of attack to delete the data related to audit information or any other crucial database information. An attacker could modify, delete, or create data or even create new accounts with full user rights on the servers that share files and folders. It allows an attacker to compromise the host operating system.
SQL injection can be classified into two types. One is blind SQL injection and the other simple SQL injection. Wherever there is a web application vulnerability, blind SQL injection can be used either to access the sensitive data or to destroy the data. The attacker can steal the data by asking a series of true or false questions through SQL statements.
All right, and a simple SQL injection script builds a SQL query by concatenating hard-coded strings together with a string entered by the user. We've kind of gone over this a little bit. Simple SQL injection can be, as we mentioned, of two types. It could be union SQL injection or it could be an error-based SQL injection. And again, just for summarizing, union SQL injection is used when the user uses the union command, and in error-based SQL injection, the attacker makes use of the database-level error messages disclosed by an application. Now, this is very useful to build a vulnerability exploit request.
Yes. And blind SQL injection is used when a web application is vulnerable to SQL injection. Blind injections are not dependent on error messages. Blind SQL injection can be used to either access the sensitive data or to destroy the data if there is a SQL injection vulnerability. Attackers can steal the data by asking a series of true or false questions through SQL statements, as we said and mentioned before. Results of the injection are not visible to the attacker, and this could be more time consuming because every time a new bit is recovered, then a new statement has to be generated.
That's right. A simple SQL injection script builds on SQL query by concatenating hard-coded strings together with a string entered by the user, like we said. The following are associated with simple SQL injection attacks. Attackers exploit database stored procedures to perpetuate their attacks. After injecting code into a particular field, legitimate code that follows is nullified through the use of end-of-the-line commands.
An attacker may gain knowledge by injecting illegal or logical incorrect requests, such as injectable parameters, data types, names of tables, and a whole bunch more. Injecting statements that are always true so that queries always return results upon evaluation of a where condition. Union select statements return the union of the intended dataset with the target dataset.
The user then checks for the vulnerability by adding a tick to the end of a .php $ID equals file. If it comes back with a MySQL error, the site is most likely vulnerable to union SQL injection. Then he proceeds to use order by to find the columns, and at the end he uses the union all select command. The attacker can make use of database-level error messages returned by the application. They're very useful for building a vulnerability exploit request. There are even chances of automated exploits based on the different error messages generated by the database server.
Attackers try to avoid detection by signature-based detection systems by obscuring the input strings.
Right.
Normally, signature-based detection systems build a database of SQL injection attack strings. They compare input strings against the signature database and run time to detect attacks. If there is a match of the attack's signatures with one in the database, then it immediately triggers an alarm. This is done in network-based key-based IDS systems and signature-based NIDS systems. So attackers tried to attack the system by bypassing the signature-based IDs or IDS. Then they tried to obscure the input strings to avoid detection, as all of them want.
Yeah.